Okay, okay. Good morning, all. Now we can start today's today's lesson. This is the fourth lesson, fourth lessons of winter unit today. So up to now we have discussed about principle of addition of vectors, principle of additions of vectors, and some of it's some special characteristic or special features. Now, today we are going to start about some derived principles, derived theorems used in principle of vector addition. Okay. So then write the topic. Derived theorems using principle of vector addition. Okay. There are the first subtopic. Vector triangle principle. Vector triangle principle. Vector triangle principle. Actually, this principle also a derived theorem from the principle of vector addition. So, as we discussed earlier, what is the principle of vector addition? Vector addition principle of vector addition for you. So, if you are given two vectors, to be added, then suppose this is vector A and suppose this is vector B. Now you know, according to the geometrical representation, this is the starting point of the first vector. The starting point of the first vector. And this is the end point. Point of first vector. You can easily determine the starting point and the end point using the arrowhead. Normally, arrowhead is directed towards the end point. Then, this is the starting point of the second vector. Arrowhead is directed towards the point D. Therefore, this should be the end point. This is the end point. This is the starting point. So, that is how we determine the starting point and the end point. Then, how to add these two vectors? We should overlap or we should coincide the end point of the first vector and the starting point of the second vector. That is the first step. Overlapping the end point of the first vector and the starting point of the second vector. If you overlap B and C, then you will have this kind of figure. And you know, this is the starting point. This is the starting point of the first vector. That means this is a starting point. This is starting point. And this is the end point of the second vector. This is the end point of the second vector. This is B. So if you construct a vector from this starting point to end point, if you construct a vector from this starting point to end point, that vector represents the addition of A and B in both magnitude and direction. Okay. To do this one, definitely these two vectors should be represented in magnitude and direction using this line segment. That means this should be the geometrical representation of that particular vector pool. Otherwise, we cannot do this. And definitely, this should be a geometrical representation. That means we have to represent those vectors into a defined scale. As well as we should draw this line segment into the exact direction of the vector. Okay, therefore, this should be a geometrical representation. That is number one. So, if you add two vectors, then that additional vector is represented using this sign. Now, if you look into this figure, this geometrical figure, so you can see this is a triangle. This is a triangle. And therefore, they have created another theorem to add two vectors. Actually, this is not another theorem. This is the principle of vector addition. This is principle of vector addition. But if you add two vectors only, we can observe a triangle. In this triangle, there are two vectors into the same direction. Means if we consider about clockwise or anti-clockwise, these two vectors are into the same direction in order. Normally we call it as these two vectors are in order. In order means they are moving into the same way. Same way means either clockwise or anti-clockwise. And this addition vector is moving into the opposite way. If these two are moving into clockwise direction, this vector, it is very clear, that is moving into the other direction. Therefore, they have formed another theorem that is called vector triangle principle, but that is valid only for addition of two vectors. If we add two vectors, the geometrical figure looks like a triangle. So, by observing some special characteristic of the triangle, they have formed or they have developed another theorem which is called vector triangle principle. Is that clear? If it is clear, please raise the hand. Okay. Then our first main topic is derived theorem using principle of vector addition. Derived theorems using principle of vector addition. Under that main topic, the first subtopic is vector triangle principle. So write this first topic and then draw this one. quickly. Okay, there I got this. There I got this. If we add two vectors, if we add if we add two vectors, if we add two vectors, according to the principle of vector addition, according to the principle of vector addition, we will always have a triangle, a triangle. Therefore, therefore, another theorem is developed. Therefore, another theorem is developed. To represent, to represent, to represent the addition of two similar vectors. Two similar vectors. Similar vectors means vectors in same type. To represent the addition of two similar vectors. Two T or W. Sorry, TW. That is called vector triangle principle. That is called vector triangle principle. Okay. පොතේ අපි මේ ප්‍රින්සිපල් එක ලියාගමු මේ කොටු කරන්න බලන්න ලියාගන්න ප්‍රින්සිපල් එක. ප්‍රින්සිපල් එක ලියන්න. මේක එහෙම මතක තියෙනවා මට. මතක තියාගන්න පුළුවන් යා මොනවද දෙන්න. Then write in another para. මේක ලියලා ඊට පස්සේ කොටු කරගන්න. If if two same type if two same type vectors if two same type vectors if two same type vectors are represented are represented in magnitude and direction are represented in magnitude and direction. By two sides of triangle two sides of a triangle two sides of a triangle two sides of a triangle taken in order come on taken in order come on then the other side taken against the order taken against the order taken against the order will represent will represent will represent will represent the addition of those two vectors, the addition of those two vectors in magnitude and direction. In magnitude and direction. In magnitude and direction. Look at this something. Look at this something. That means the theorem says if two vectors are represented in magnitude and direction by two sides of triangle which are into the same mode. Same mode means they are moving into the same direction. These two vectors are moving into the same direction. Then the other side which are taken into the against the order. That vector will represent the addition of these two. Actually, this is not another theorem. That is not another theorem that should be memorized. Actually, that is based on the first base theorem. What is the base theorem? Principle of vector addition. Principle of vector addition. Therefore, if we have two vectors, the geometrical figure looks like a triangle. That's why they have developed another theorem which is called vector principle of vector triangle principle. And therefore, no need to try to memorize this thing, but understand this is a derived theorem from the base theorem. And so, most important thing is this this relationship with them. Look at this one. AB vector plus BC vector is equal AC vector. Okay. So that means if you have this kind of algebraical expression, so this is an algebraical expression. So if you have this kind of algebraical expression, now it is very you can understand this one by Balanga. Look at this one. AB plus BC is equal AC vector. So you know this is the starting point. This is the starting point of the first vector. This is the end point of this first vector. And it is very clear the end point of the first vector is same as the starting point of the second vector. End point of the first vector is equal to the starting point of the second vector. These two are equal. Therefore, AB plus BC means that is equal to AC. AC means the starting point of the first vector and end point of the second vector. B missing. Therefore, you can understand if you are given algebraical expressions. If you are given some algebraical expressions to be added, then you can clearly understand. You can add these kind of expressions very easily. If the endpoint of one vector is equal to the starting point of another vector, that means they are overlap. Therefore, addition of those two is equal A to C. A to C. Is that clear? If it is clear, please raise the hand. තේරුණා තුස්සන්? ඒක තේරුණා තුස්සන්? Okay. හරි. දැන් යන කලින් දීපු එක පොඩ්ඩක් කොටු කරගන්න පුතේ. Then draw this one and write this one also. Okay. හරිද පුතේ? I finish? If you complete writing, please raise the hand. Thank you. The right topic vector parallelogram law. Vector parallelogram law. This is second one. This is second one. So this is the second principle which is derived from principle of vector addition, vector parallelogram law. Actually, this law is the most important law because there are a lot of question types using this law. Okay, using this law. So this is the mathematical part of vector addition principle. This is the mathematical part of it. Yeah. Right. Then suppose this one. Suppose there are two vectors. There are two vectors which are acting at the same point. Suppose there are two vectors whose starting point are equal. That means this kind of one. So this vector is AB, this vector is AC. Suppose this is A, this is B. Now these two vectors, look at this one. Now the starting point of these two vectors are equal. They are equal to it. Therefore, in such cases, if you want to add these two, what should we do? We cannot apply principle of vector addition directly, no, Pute. We cannot apply. Because now the starting point of the second vector and starting point of the first vector, they are equal. Therefore, I cannot overlap the starting point of the second vector and the end point of the first vector. We cannot overlap. Therefore, in such cases, there should be another methodology to add such kind of vectors. Remember what I'm saying. Understand. Not remember. Understand what I'm saying. Look at this one. If there are two vectors which are active at the same point, that means if the starting point of those two vectors are equal, then we cannot overlap the starting point of the second vector and the end point of the first vector. Because the starting point of the second vector is equal to the starting point of the first vector. That is the problem. Therefore, in such cases, we cannot apply principle of vector addition directly. Actually, we can apply, but we cannot apply directly. Is that clear? If it is clear, please raise the hand. Scenario. So in such cases, there should be another methodology to add such kind of vectors. Okay, so that methodology is vector parallelogram law. Actually, this one also is developed using principle of vector addition, but the special thing is this law is developed to add two vectors which are acting at the same starting point. But this principle can be used to add any vectors, but the reason to develop this vector is this. Okay. Then write the topic and draw this one. Okay. They write under this. suppose there are two vectors whose starting points are equal. Suppose there are two vectors whose starting points are equal. If we need to add, if we need to add those kind of vectors, if we need to add those kind of vectors, we cannot overlap, we cannot overlap the endpoint of the first vector, the endpoint of the first vector with the starting point of the second vector, with the starting point of the second vector. The starting point of the second vector directly. Therefore, in such cases, we cannot apply the principle of vector addition. Therefore, in such cases, we cannot apply the principle of vector addition directly. They write in another para. There should be a methodology. There should be a methodology there should be a methodology to add those kind of vectors. അതായത് Please repeat the word. Okay, suppose you are given this kind of two vectors. Now these two vectors start from this point. Therefore, the starting point of both vectors are equal. Therefore, if you want to add P and Q, we cannot apply principle of vector addition directly. We cannot overlap the starting point of the second vector with the starting point of the end point of the first vector. And therefore, in such cases, we can do a construction. We can do a construction to add those kind of two vectors. So what is the construction? Now it is very clear these two are two adjacent sides to two adjacent sides. These two are straight lines. Therefore, we can consider these two straight lines are two adjacent sides. So keeping these two straight lines are two adjacent sides, we can construct the parallel. So we can draw a parallel line to AD. We can draw a parallel line to AD starting from B. We can draw a parallel line to AD starting from B. Then we can draw a parallel line to AB starting point D. Then we can complete the parallel. Then we can complete the paragraph with A. Suppose this one B, this is C. Yeah. Now, look at this one. Now these two are two parallel sides. A, B, and D, C are two parallel sides. Now you know. Construct A, B, C, D parallel. So if we construct ABCD parallelogram, you know AB is parallel to DC. AB and DC are two opposite sides. If they are two opposite sides, they are parallel to each other. The other thing is the length of AB. The length of AB is equal the length of DC. They are equal in magnitude and equal in direction too. Therefore, AB is equal and parallel with DC. Therefore, it is very clear if we consider about AB vector should be equal to DC vector. Therefore, if we represent a vector, from AB, that vector should be equal to the vector represented by DC. Because AB and DC are two sides which are equal in magnitude, and equal in direction, equal in magnitude as well as equal in direction. Therefore, if we represent a vector, from AB, it should be equal to the vector represented by DC. Therefore, definitely DC vector should be equal to Q. Therefore, DC vector should be equal to Q vector. Did you get my point? If you get my point, please raise the hand. There are the same. Yoshita, please. So this one is Q vector. Now look into this figure. Look into this figure. Now it is very clear. If we consider about AD and DC vectors, AD and DC vectors, they are represented in magnitude and direction by these two sides. Look at this one. AD, this is the endpoint of P vector. This is the endpoint of P vector and the starting point of the Q vector. So point D is the endpoint. This is the endpoint of P vector. This is the endpoint of P vector. As well as this one is equal to the starting point of Q vector. The starting point of Q vector. Therefore, now they are overlap. Now they are overlap. Now they are overlap. Now tell me what is the addition vector of P and Q? What is the vector that represents P plus Q? Tag again. Now AD plus DC. So what is the vector that represents P plus Q? Tell me. Give me an answer.
AC.
AC. AC with it. Okay. AD plus ADC means now it is AC vector. Now it is AC. Therefore, AC vector P plus Q should be represented by AC vector. P plus Q. Is that clear? If it is clear, please raise the hand. So this is called vector parallelogram theorem or vector parallelogram law Bute. So if you are given two vectors whose the starting point are same, then the addition of those two vectors is represented by the diagonal of the parallelogram which is constructed like this. So how to construct that parallelogram? You have to consider these two sides are two adjacent sides. You have to consider these two sides are two adjacent sides of that parallelogram, and you have to construct that parallelogram. So once you construct that parallelogram, the diagonal that goes through this point, represents the addition of these two vectors. Okay. Okay, then draw this one. This is Q vector. This is P vector. Here B, A, here D. Draw this one. Don't draw this one. Just draw this. They write this one. They write on this. Write on this. If we are given this kind of two vectors, if we are given this kind of two vectors to be added, to be added, we should construct, we should construct we can construct a paragon by keeping AB and AD are two adjacent sides. By keeping AB and AD are two adjacent sides. Okay. Then draw this paragon and write from here to the end. The finish පොතේ හරිද? If you complete writing, please may give me a thumb. Thank you. මේක මොනවා මේ අර ඕගොල්ලන්ට අර කියන්නා වගේ මේක නිකන් කටපාඩම් කරගන්න පුළුවන්. මේ කටපාඩම් කරලා ඇත්තටම ෆිසික්ස් කුඩ යන්න බෑ. ෆිසික්ස් අනිවාර්යෙන් හොඳට තේරුම් ගන්න ඕනේ පොතේ අනිවාර්යෙන් අපි හරියට බේසික් ටික හරියටම අපි අන්ඩර්ස්ටෑන්ඩ් කරගන්න ඕනේ. හරිද? නැත්නම් වෙක්ටර් පරිවර්තන වල කියන්නේ මේක මොකද්ද? මේ ට්‍රයිඇන්ගල් වල කියන්නේ මේක ඔය වගේ අපිට මේව කරන්න පුළුවන්. හරිද? හැබැයි මේ ඔක්කොම බේස් වෙලා තියෙන අර මූලික මේ ප්‍රින්සිපල් එකෙන් මම ඒකයි ප්‍රින්සිපල් එක කතා කරේ. මේ ප්‍රින්සිපල් එක කතා කරේ නැත්නම් මේ ප්‍රින්සිපල් එක කතා කරන්න කියලා දෙයක් වරවල නැහැ. නමුත් තේරුම් ගන්න එක තේරුම් ගන්නට අවශ්‍ය මාරම ලේසි මේ මොකද තේරෙන මේ වෙක්ටර්ස් ඇතුලේ තියෙන තනිකරම කතන්දරේ විතරයි. හරි. ඒක නිසා වෙක්ටර්ස් ගත්තොත් එහෙම ඇත්තටම ඔය කියන එකම එක සිංගල් ප්‍රින්සිපල් එක තමයි තියෙන්නේ. ඒක තමයි ඩෙවලොප් වෙලා තියෙන්නේ එක සෙක්ෂන්ස් වල. හරිද? අනිවාර්යෙන් හොඳට මතක තියාගන්න තමයි ඕගොල්ලන්ගේ ස්ටාර්ටින් ලෙවල් එකේ ඉන්නේ. ෆිසික්ස් කියලා කියන්නේ අනිත් සබ්ජෙක්ට්ස් වගේ නෙමෙයි. ඔයා මැත්ස් කරත් බයෝ කරත් ෆිසික්ස් කියලා කියන්නේ අනිත් සබ්ජෙක්ට් දෙකට වඩා වෙනස්. ඒකට හේතුව මැත්ස් කරා වුණත් පුතේ මැත්ස් එක වුණත් අපිට සාමාන්‍යයෙන් අපි කියන්නේ අපි ක්වෙස්චන්ස් දීපයක් කරාට පස්සේ ක්වෙස්චන්ස් වලට යන ඊළඟ ක්වෙස්චන් එක අපිට එහෙම කරගන්න පුළුවන්. ඒක එහෙම අර තියරිටිකල් බෑග්ග්‍රවුන්ඩ් එක ඕනේ නැත්නම් නැහැ. නමුත් මැතමැටිකල් ඇබිලිටි එක තියෙනවා. ළමෙක්ට මැතමැටිකල් ඇබිලිටි එක තියෙනවා යන්න පුළුවන්. හැබැයි ෆිසික්ස් වලදී මැතමැටිකල් ඇබිලිටි තියෙන එක වාසි. නමුත් මැතමැටිකල් ඇබිලිටි එක තිබ්බා කියලා ළමෙක්ට එකක් ගන්න බෑ. ඒක හොඳට තේරුම් ගන්න. මැතමැටිකල් හොඳ මැත්ස් කාරයෙක් වෙන්න පුළුවන්. ඔයාලා හොඳට මැත්ස් පුළුවන් වෙන්න පුළුවන්. ඒක වාට අර ප්‍රී ක්වොලිෆිකේෂන් එක. හරිද? ඒ වුණාට ඔයා මේ සබ්ජෙක්ට් එක හරියට අන්ඩර්ස්ටෑන්ඩ් කරගත්තේ නැත්නම් ඒකට යන්න බෑ. හැබැයි මතක තියාගන්න ලේසි මේක තේරුම් ගන්න හරියට මේ විදිහට බේසික් කතා කරමු. හරිද? එහෙම නැතුව අපි මේක කියලා පැලස්තරගෙන ගියොත් ඔක වැඩේ කරගන්න හම්බෙන්නේ නැහැ. නිසා ඔයගොල්ලෝ පාඩම් කරනකොට අනිවාර්යෙන් මේ තේරුම් කරන්න ඒ තේරුම් ගත්තදී ඒ විදිහට මේ පාඩම් කරන. කියන්නේ උඩ තියෙන දේ කියන්නේ ඉක්වේෂන් එක දුන්නොත් ඒ ඉක්වේෂන් එක විතරක් මතක තියාගෙන ඉතුරු ඔක්කොම අමතක කරන එක නෙවෙයි මම කියන්නේ. අනිකරම මේ තියරම් එක හරියටම අන්ඩර්ස්ටෑන්ඩ් කරන විදිහට පාඩම් කරන්න. හරි. මෙහෙම නැතු කියන්නේ ඒක තේරුම් ගන්න පුළුවන් එකම විදිහ තමයි පුතේ ඔයා තව කෙනෙක්ට ටීච් කරන්න. තව කෙනෙක් කියලා මනුස්සයෙක් කියන්න ඕන නම් සෙල්ෆ් ටීචින් කරන්න. සෙල්ෆ් ටීච් කරනකොට ඔයාට එක්ස්ප්ලেইন කරගන්න බැරි නම් මොකක් හරි එකක් ඒ කියන්නේ ඔයා තව පොඩ්ඩක් ඒක මේ බලා ගන්න ඕනේ. හරි. ඒ කියන්නේ ඔයා කියන්නේ සමහර කෙනෙක්ට පුතේ අර මේ හිතේ තියෙන දේ කියා ගන්න බැරි අවස්ථා තියෙනවානේ. හිතේ තියෙන දේ කියා ගන්න බැරුණවත් බෑ කියලා කතා කරා. නමුත් එහෙම නෙවෙයි. තමුන්ට හිතෙන්නවත් නැත්තම් මේක හරියට එතන ප්‍රශ්නයක් තියෙනවා. හරි. ඒ නිසා මොකක් හරි තියරම් එකක් මොකක් හරි ෆිසික්ස් කෙමිස්ට්‍රි ඒ වගේ තමයි. නමුත් මොකක් හරි ඒ වගේ මොකක් හරි තියරම් එකක් අපි තේරුම් ගනිද්දී ඒක තේරුම් ගන්න තියෙන ලේසිම විදිහ තමයි ඔක්කොම ටික ඉවරනට පස්සේ සෙල්ෆ් ටීච් කරනවා. සෙල්ෆ් ටීච් කරනකොට ඔයාට ඒක තියාගන්න බැයි නේද? මේක ඔයාට අනිවාර්ය ලොජිකලි කියන්න බෑ පුතේ. ලොජිකලි කියන්න මෙන්න මේක නිසා තමයි මේක වෙන්නේ. මේක නිසා තමයි මේක වෙන්නේ. දැන් මම අර කතා කරා වගේ ලොජිකලි කියන්නේ. එහෙම ලොජිකලි ඕගොල්ලන්ට කියාගන්න බැයි නම් අනිවාර්යෙන් එතන ආයෙ පාර පොඩ්ඩක් බලා ගන්න. බලලා තනියම තේරුම් ගන්න උත්සාහ කරන්න. හරි. මම මේක ඕගොල්ලන්ට කලින් කියලා ඔය පන්තිලක් මම කියලා දෙනවා. පුතේ ටීචර් කෙනෙක් විදිහට අපිට කරන්න පුළුවන් එකම දේ ඔයාලට යන පාත් එක කියලා දෙන්න. ඒක නිසා අර එස් මට්ටමට පහළින් ඉන්න කෙනෙක් කියන්නේ ෆේල් වෙන මට්ටමේ ඉන්න කෙනෙක් මොකක් හරි කරලා මොකක් හරි ප්‍රශ්නයක් කරලා පාස් කරවන්න මොකක් හරි දෙයක් කරන්න පුළුවන්. ඒ ළමයා මොකක් උනන්දුවක් තියෙනවා. හැබැයි අපිට බෑ ඒකක් කරන්න දෙන්න. හොඳට මතක තියාගන්න කවුරු කියනවා ඒකක් කරන්න දෙනවා කියලා ඒක කරන්න බෑ. ඒක කරන්න බෑ. ඒකක් කරන්න දෙන්න මට බෑ. මට කරන්න පුළුවන් ඒකට යන පාත් එක කියලා දෙන්න පුළුවන්. ඔයා තනියම තේරුම් ගන්නකම් ඔයා මේ වැඩේ තනියම අන්ඩර්ස්ටෑන්ඩ් කරගන්නකම් පුතේ යන්න බෑ එහෙම. A සහ B කියලා කියන්නේ ඇත්තට මාරම ඇඩ්වාන්ස් මාක් එකක් ෆිසික්ස් වල. මොකද එතනට යනවා ඔයා තනියම වැඩ කරන්න ඕන. තනියම වැඩ නොකර කිසිම විදියකින් එතනට යන්න බෑ මොන තරම් සර් හොඳ වුණත්. ඒක මතක තියාගන්න. ඒක නිසා ගොඩක් ළමයි දැන් ඔය අපි ගත්තොත් එහෙම මේ ෆීල්ඩ් එක ගත්තොත් එහෙම අච්චර මේකද ඒ අරන් දෙනා බී අරන් දෙනා කියනකොට ඒකම අරන් දෙන්න බෑ ඇත්ත කතන්දර. හරි. එහෙම මේ අරන් දෙන්න බුලත වගේ. නමුත් S එකක් නම් මොකක් එහෙම කරන්න පුළුවන්. ඒ කියන්නේ ෆීල්ඩ් එක මට්ටම වෙනවා. ඒක S එකට අරගෙන මොකක් හරි දෙයක් කරන්න පුළුවන් ටීචර් කෙනෙක්ට. හරි. ඒ කියන්නේ ඒ අරන් දෙන්න බී අරන් දෙන්න හෙල්ප් නොකරන නෙවෙයි. ඒ කියන්නේ අපි පාත් එක කියා දෙනවා අපි සබ්ජෙක්ට් එක කියා දෙනවා ඒ හෙල්ප් එක තියෙනවා. නමුත් ඒ පාස් එකට යන ඒ පාස් එකට යන දේ කරන්න ඕන තනිකර ඕගොල්ලෝ. හරි. ඒක තනිකරම ඕගොල්ලන්ගේ. ඒ නිසා ඒ රිසල්ට් එක ඒ තනිකරම ඒ රෙස්පොන්සිබිලිටි එක තනිකරම කොණ්ඩගෙන ඕගොල්ලෝ වටාම ඒ නිසා කාර්යවත් රිසල්ට් යන්නේ නෙවෙයි ඕගොල්ලෝගේ රිසල්ට් එක. හරි. ඒ නිසා හොඳට මතක තියාගන්න මේ පාඩම් කරනකොට ඔය ෆිසික්ස් වගේ දෙයක් ඔයාලා ස්ටඩි කරනකොට අනිවාර්යෙන් ඒක යූස් කරන්න කියලා කියන්නේ තමුන්ට සබ්ජෙක්ට් එක තේරුණා නැද්ද කියලා බලන්න මම කිව්වා විදි දෙකක් තියෙනවා කියලා. මුලින් අපි මේ පාඩම තේරුණා නම් ඉතින් මේ ක්ලාස් එකේදී ඒක හරි. ඊට පස්සේ අනිවාර්යෙන් කොච්චර තේරුණාවත් ඒ නොලෙජ් එක වාගේ නොලෙජ් එකක් කරගන්න ඕනේ. වාගේ නොලෙජ් එකක් කරගන්නේ කොහොමද? පුළුවන් නම් සෙල්ෆ් ටිච් කරන්න. ඊළඟට ටියුට් එක කරන් ටියුට් එක කරලා ක්වෙස්චන්ස් කරලා ඒ ක්වෙස්චන්ස් කරන ඇබිලිටි කාවට පස්සේ අනිවාර්යෙන් පාස් පේපර් ක්වෙස්චන්ස් කරන්න. ඒක මස්ට් එකක්. ඒක මස්ට් එකක්. මොකක් හරි යුනිට් එකක් ඉවරුනාට පස්සේ ඒකට දාලා පාස් පේපර් ක්වෙස්චන්ස් ඔක්කොම ටික කරන්න. ඒ පාස් පේපර් ක්වෙස්චන්ස් ඔක්කොම කරලා ඔයාලට more than 85% ගන්න පුළුවන් නම් අන්න ඔයා සේෆ් සයිඩ් එකේ ඉන්න. more than 85% ගන්න පුළුවන් නම් ඔයා සේෆ් සයිඩ් එකේ ඉන්නකොට. හරි. එහෙම නැත්නම් ඒ කියන්නේ සාමාන්‍ය 75% වලටත් වඩා අඩු වෙන්න නම් මට අවිලා තියෙන ආයෙසරක් ස්ටඩි කරන්න. ආයෙපාරක් ස්ටඩි කරලා ආයෙසරක් බලන්න go through කරලා ආයෙ තේරෙච්ච තැනට ආයෙසරක් අහගෙන ඒ ටික අනිවාර්යෙන් ඔය සයිකල් එක යන්න ඕනේ. කියන්නේ මොකක් හරි යුනිට් එකක් ඉවරනාට පස්සේ ඒ යුනිට් එක සබ් යුනිට් එකක් වගේ කියන්නේ සබ් යුනිට් එකට දාන පාස් පේපර් MCQ ටික පාස් පේපර් SST එක SST ස්ට්‍රක්චර් තියෙනවා ස්ට්‍රක්චර් ටික අනිවාර්යෙන් කල්ලි කරගන්න. හරි. ඒක මම ඇඟිල්ලෙන් එන බලන්නේ නැහැ. හැබැයි අපි කරමු. අපි EQR කියලා ඒ කියන්නේ exam questions reviewing කියලා අපි කරමු. ඒ කරන්නේ ඉතින් එකපාරක් ඊට පස්සේ ආයසර රිවිෂන් එකේ ආයසර අන්තිමට පේපර් වලදී ආයසර කොහොමද අපි තුන් පාරක් විතර කරමු. හැබැයි ඒක ක්ලාස් එකේ කරනවා කියලා ඕක නොකර ඉන්න බෑ. අනිවාර්යයෙන් ඕක තනින් කරන්න. මොකද ඒකේ තමයි මම තේරුම් ගන්නේ මම මේ යුනිට් එක තේරුම් ගත්තද කියලා. ඒ නිසා අනිවාර්යයෙන් ඒක පොඩ්ඩක් පොඩි තියාගන්න. හරි. හරි. Okay. Then we can go to the lesson, okay? Okay, then I got this. Therefore, the addition of P vector and Q vector. P vector is like this. The addition of P vector and Q vector. is given by AC diagonal is given by AC diagonal. This is called principle of, sorry, this is called vector paradigm law. This is called vector paradigm law. Alright. They write in another para. මේක ලියලා කොටු කරන්න මෙතන මම මේ ලෝ එක දෙන්නේ පුතේ. මේක ලියලා කොටු කරගන්න. When two similar vectors, sorry, when two similar types of vectors to similar given same way equal vectors when two similar types of vectors are represented in magnitude and direction are represented in magnitude and direction by two adjacent sides of a paragon. By two adjacent sides of a paragon, comma, the diagonal in between the above two sides. The diagonal in between the above two sides the diagonal in between the above two sides gives the addition of two vectors, the addition of two vectors the addition of two vectors in magnitude and direction. In magnitude and direction. Oh, this is the theorem. That is the theorem. Okay. Then I do special note. Then I do special note. Special note means not and that. Okay. It's the addition of two vectors. Normally we call that addition vector as the resultant vector. The resultant vector of those two vectors. So resultant vectors means the resultant vector means the vector that can replace the above two vectors is called the resultant vector. Actually, resultant vector gives all the characteristic of the other two vectors. Okay. And actually, I will define resultant vector after doing this one. But until then, this term can be in our Tyutpute. Therefore, we have to actually, this is not the definition, but we can just write about resultant vector. Okay, that is the term. Okay. Not understood. Addition of, sorry, the addition vector. The addition vector is also known as the resultant vector. Is also known as the resultant vector. Actually, I will define this too. Okay, I will define kind of resultant. The addition vector is also known as the resultant vector. Resultant vector. Resultant vector. What the resultant vector means like this. Suppose if we apply 10 Newton force into this direction and another 5 Newton force into this direction, you know the addition of those two is 15. No, addition of those two is 15 because both vectors are into the same direction. Therefore, instead of these two, I can apply 15 Newton force into the same direction. Therefore, the resultant vector means that is a single vector. That is a single vector that can be replaced a vector system. Vector system. Now there are only two vectors in this system today, but sometimes there may be lot of vectors. More than two vectors. Therefore, resultant vector means there is a single vector that can be replaced all the vectors in the system. Therefore, the result vector gives the same end result as the vector system. Therefore, there is no difference between this vector system and this vector. Both give the same end result. Therefore, the only difference is that now there are two vectors. Here, there's only one vector. Therefore, we can reduce the number of vectors using this resultant vector method. Therefore, resultant vector means that is the single vector that can be replaced or that can give the same end result as a vector system. Is that clear? If you get the term, please raise the hand. Okay. They write on that. The second is point. The resultant vector is the single vector that can be replaced a vector system that can replace a vector system. Okay. Okay, then our topic. Finding the magnitude and direction. Finding the magnitude and direction of the addition vector. Finding the magnitude and direction of the addition vector. In vector parallelogram law. Now look at this topic. Now there's a parallelogram topic. Now there's a parallelogram. AB side of the parallelogram represents P vector. AB side of the parallelogram is represents Q vector. Okay. Then the addition of P and Q. Addition means resultant. The resultant of P and Q is represented by AC diagonal. So that is vector parallelogram law. Now we are going to determine the magnitude of AC, magnitude of this R as well as the direction. So if a vector is represented by a line segment, remember this. Understand this. If a vector is represented by a line segment, the magnitude of this vector should be corresponding to this length. Definitely should be corresponding to therefore, the magnitude of this vector should be equal the length of this line segment, If it is represented by a line segment, the length should be corresponding to the magnitude. Therefore, instead of magnitude, I can represent it by the length. Is that clear? If it is clear, please raise the hand. Therefore, magnitude of P vector is equal AB length. AB length, we can take it as P. We can take it as P. That is a, we can take it as P. Then, magnitude of Q vector is equal AD length. And that is equal Q. Now, if we want to determine the magnitude of addition vector, then what should you determine? According to that argument, if you want to determine the magnitude of R, then what should you determine? Definitely AC length. Simple, no? You have to determine AC length. AC length is equal the magnitude of R vector. Is that clear? If you get my argument, please raise the hand. Argument Thank you. Then, definitely the magnitude of R vector, therefore, magnitude of R vector is equal AC length. So you have to determine AC length. What is AC length? Here, theta. Theta means that is the angle between P vector and Q vector. That is the angle between P vector and Q vector. Theta. Theta means the angle between P vector and Q vector. So if it is theta, now you know this is a parallelogram. Therefore, AD is parallel to BC. Therefore, CBE angle. This should be equal theta corresponding angles. No, this should be equal theta corresponding angles. Is that clear? If it is clear, please raise the hand. Okay. Now, you know this length is equal to P. And you know as these two sides are parallel in a parallelogram, and they are two opposite sides to the in the two opposite sides, definitely this side should be equal to Q. Make a Q. This length should be equal to. Is that clear? If it is clear, please raise the hand. If it is clear, please raise the hand. This side is equal to because they are in parallel. As A, B, C, D is a parallelogram. AD length is equal BC length, and that is Q. That is Q. And CBE angle is equal to theta. CBE angle is equal to theta. So, today, you know this length, BC length, and this angle. So, if you know these two, you can determine this length and this one. You can determine X and Y. So, if you know the hypotenuse and angle, you can determine the adjacent side by Q cos theta. X is equal Q cos theta. You know this chart. Adjacent side is equal hypotenuse into cos theta. Opposite side is equal hypotenuse into sin theta. P cos theta, P sin theta. We know this one. No? Therefore, using BCE, using BCE triangle. Okay, it is very clear. Cos theta is equal adjacent side to hypotenuse. Cos theta is equal adjacent side X over hypotenuse Q. Therefore, adjacent side is equal Q cos theta. That is number one. Adjacent side is equal Q cos theta. If you got that one, please raise the hand. Then hypotenuse, sorry, I'm not hypotenuse, opposite side. Sin theta is equal opposite side of hypotenuse y over x. Y over q. Therefore, y is equal q sin theta. This is true. Yeah. So you know x as well y. Then look at this one. You need to determine AC. You need to determine AC length. You need to determine AC length. So if we can build a right angle triangle with AC side, then we can easily determine AC length. AC length. Now tell me, what is a right angle triangle that can be used to determine AC? That can be used to determine AC. What is the right angle triangle that can be used to determine AC? AC හොයාගන්න පුළුවන් right angle triangle එක මොකක්ද? Please give an answer. එකල answer කරන්න chat box එකේ දාන්න.
Easy.
Yes. A C E. A C E. If I use A C E right angle triangle, then we can determine AC. Therefore, using A C E right angle triangle. If you use a square ACE rectangle triangle, today, look at this one. This is A C E. A C. Put A to E. What is A to E length? A to E length is equal P plus X. P plus X. Therefore, this is equal P plus X. And CE is equal Y put it. C is equal Y. Is that clear? A equal P plus X. C equal Y. If you got that down, please raise the hand. They want to do something. Then AC squared, then AC squared should be equal to Y P plus X, P plus X, the entire square plus Y square. Is that clear? If you got this relationship, please stress that. तेरा तो सन ये relationship पे तेरा तो सन पहले मतलब Pythagoras law के मेरा Pythagoras law के this side is P plus S put it. This side is P plus S. This side is Y. Therefore, using Pythagoras theorem, AC square should be equal square of this side plus square of this side. The square of this side means this side length is P plus X. Therefore, P plus X is square. The square of this side means this side length is Y square. Therefore, P plus X squared plus Y squared is equal AC squared. If you got that one, please raise the hand. Start card. Thank you. Okay, then AC squared is equal P squared plus 2px plus x squared plus y squared. S squared plus y squared. Have like them done. Therefore, AC squared is equal x squared. Sorry, 2px, p squared plus two p x is equal q cos theta. X squared means q cos theta squared plus y squared means q sin theta squared. Q sin theta squared. Therefore, I can write this one again. AC squared is equal p squared plus 2pq cos theta plus here q cos theta squared, that means q squared cos squared theta, q squared cos squared theta plus here q sin theta squared means q squared sin squared theta, q squared sin squared theta, q squared sin squared theta. You know AC means R. Therefore, instead of AC, I can write it as R. Therefore, R squared is equal P squared plus 2pq cos theta plus here q squared cos squared theta. Here, that's q squared cos squared theta plus q squared sin squared theta. Therefore, you can See, q squared is a common factor for these two terms. Therefore, you can take it out. Therefore, q squared, if you take it out, this is equal cos squared theta plus sin squared theta. Cos squared theta plus sin squared theta. So you know in trigonometry, cos squared theta plus sin squared theta is equal 1. This is equal to 1. Cos squared theta plus sin squared theta is equal to 1 according to trigonometry. Okay. Therefore, r squared is equal p squared plus 2pq cos theta plus q squared into 1. Q squared into 1 means q squared. Q squared. Therefore, I can write r squared like this. Already. R squared is equal p squared plus q squared plus 2pq cos theta. 2pq cos theta. If you got my explanation, please raise the hand. May calculation it here na question. I have given this. Okay. They write this one. May nagdalagan. May nagdalagan. Okay. I have finished. I have completed writing. If you complete writing, please may give me a thumb. Now we know the magnitude, Pute. Now we know the magnitude. Therefore, now we can determine the direction of the resultant vector. Direction of the resultant vector too. But how to determine the direction? How to determine the direction? Actually, direction can be represented using an angle. The direction of a vector can be represented by using an angle. And using an angle, we can say this vector is into the east. This is into the west or north. Or this is 30 degree into the clockwise direction to the north. And therefore, likewise, we can say or we can represent the direction using an angle. Therefore, that angle may be an angle between the horizontal and vector. It may be an angle between the vertical and the vector. So if it is vertical, if you know this one is vertical, then we can determine or we can represent the direction of vector with the angle with the vertical and the vector. Or we can represent a vector by the angle between the horizontal and the vector. Or otherwise, we can represent the direction of vector using an angle between two vectors. That also correct. Therefore, the direction of vector can be represented by an angle between the vector and a non-direction. That non-direction may be horizontal, it may be vertical, it may be some kind of another vector. Therefore, so in this case, we use the angle between the P vector and the resultant vector. We are going to use the angle between P vector and the resultant vector to represent the direction of R. Therefore, the direction of R is equal to the angle between R and P. Therefore, you need to determine alpha. Again, I can use ACE triangle. If you consider about ACE triangle, this angle is alpha. Here R. And AE length is equal P plus X. AE length is equal P plus X. And C length is equal Y to P. This is equal Y. Okay. Therefore, you know the opposite side as well as the adjacent side to this angle, the opposite side and the adjacent side. So if you know the opposite side and adjacent side, I can write tan alpha. Tan alpha is equal Y over P plus X. Okay, therefore tan alpha is equal Y means Q sin theta divided by P plus X means Q cos theta. Therefore, this is the angle. Angle is equal, tan alpha is equal Q sin theta over P plus Q cos theta. Therefore, if you want to determine angle is equal tan inverse Q sin theta over P plus Q cos theta. So this is the direction. This is the direction of if you get that one, please raise the hand. Tagalan. Have completed? Okay. Okay, Budit. Now we can complete today's class as well. Today's my first lesson. And now you can go through these questions. Look at the take the tube. In the second page of the tube, there are questions based on question on principle of vector addition, vector triangle principle, and vector parallelogram theorem. So there are questions based on those theorems. In the first question, you have to apply r square equal p square plus q square 2p cos theta equation. So there are two sections A and B. Each section there are 5 questions. So altogether there are 10 questions. So please do the 10 questions. Okay. Then after completion of that 10 question, please do the questions up to question number 5. Please do the questions up to question number 5. There are 10 questions. There are 10 questions in first question. Then after question number 2, 3, 4, and 5. Therefore, question up to question number 5 you have to do when you come to the evening class. Okay. So we can complete today's class, today's morning class today. So please go through these questions and then we can discuss them. Okay. Everyone, we can complete today's class by now. Okay, then have a nice day. I want to